the person's age 2 times. So we can actually save this age in a variable and then reuse that value. So above the if statement, let's create a variable using const, and let's name this variable age, and we'll make it equal to 15. Remember, the best practice for creating a variable is to use const by default, and only use let if we're going to change this value later. And now that we saved this number in a variable, we can use the variable inside the if statement. So we'll replace 15 with age, and here as well with age. So this will take whatever value is inside the variable and substitute it into the code. If we save, the if statement works the same way as before, and we run this line. Okay, now we're ready to use booleans and if statements to do a project. We're going to build a rock, paper, scissors game. First, let's take a look at the project. We're going to go to our browser, and at the top, create a new tab, and we're going to type here supersimple.dev/projects/booleans and press enter. Here we can see a simple version of a rock, paper, scissors game. And if we click this link, it will take us to the final version of this game. So in this game, we can pick a move, and then the computer will pick a random move, and it will show us the result. And we also have a score of how many times we won, lost, and tied. So we're going to build this as we go through the course. But for now, let's go back, and we're going to start by building this simple version of the game. So how this simple version works is we click one of these buttons to pick a move. So let's pick rock. Then the computer will randomly pick a move. In this case, it's paper, but for you, it might be different. And it will compare the two moves and display the results in this pop-up. So the rules of rock, paper, scissors are rock beats scissors, paper beats rock, and scissors beats paper. Let's press OK, and we'll get started on this project. First, we'll create a new HTML file just for this project. Let's go to our code editor and click here and create a new file. And we're going to name this file 06-rock-paper-scissors.html and press enter. Next, let's copy all the code from booleans.html into this new file. So we'll open this again, and then Control A or Command A to select all the code, and then right click, copy, and in here, right click and paste. Let's close this and prepare this file. So we'll change this to rock, paper, scissors, and remove all of the JavaScript code that we had before. Finally, let's save and open this file in the browser by right-clicking and then open with Live Server. Let's take a look at the project again. So we're going to start by creating the text first, because this text is in the final version of the project. So in our HTML, we're going to create a paragraph element for this text. So less than, p greater than, and the closing tag less than /p greater than. Inside our paragraph, we're going to have the text rock, paper, scissors. Next, let's create the buttons. So we'll go to our HTML and create a button. And inside this first button, we'll have the text rock. Let's create another button. This one will be paper. And we'll create the last button. This one will be scissors. Now let's save and check our new tab. And now we created all the elements that we need. Next, let's make these elements interactive with JavaScript. So when writing JavaScript, a good strategy is to think about what steps we need to do and then convert those steps into code. So here, when we click a button, the first step is the computer will randomly select a move, and then we're going to compare the moves to get the result. And finally, we'll display the result in a pop-up. By the way, this is called an algorithm. An algorithm is a set of steps to complete a task or to solve a problem. Now that we know what steps we need to do, we're going to convert these steps or this algorithm into code. First, we're going to run some JavaScript when we click these buttons. So let's use the onClick attribute again. We'll go to the opening tag of the button and type onClick equals double quotes. And then inside these double quotes, we can add our JavaScript. So now we have to figure out how to randomly select a move for the computer. To do this, we need to learn a new piece of JavaScript code. So here, we're going to type capital M math.random, open bracket, close bracket. Math.random generates a random number between 0 and 1. So if we console.log this, console.log, and save, and click this button, and then check in our console by right-clicking, inspect, and the console, it will display a random number between 0 and 1. If we click this button again, it will generate a different random number. So every time we run math.random, it generates a different random number between 0 and 1. Now, to be more precise, it actually generates a number greater than equal to 0 and less than 1. Now let's save this random number in a variable so we can use it later. So we'll replace the console.log with const and then a variable name. Let's just name it random capital N number and then equals. So we saved this random number inside this variable. Next, we need a way to convert this random number into a move, like rock, paper, or scissors. To do this, let's imagine the space between 0 and 1, and then divide this space into 3 equal parts. Each part represents a move. If we generate a random number and it's between 0 and 1/3, the move will be rock. If it's between 1/3 and 2/3, the move will be paper. And if it's between 2/3 and 1, the move will be scissors. This is how we can convert the random number into a move. And this will give the computer an equal chance of picking rock, paper, or scissors. Now let's convert these steps into code. And an if statement is the perfect solution for this. This already looks like an if statement. So in our onClick attribute, let's add some new lines and type if, brackets, and curly brackets. For this first condition, we're going to check if the random number is between 0 and 1/3. So let's check if random number is greater than or equal to 0 But in this case, we also need to check that random number is less than 1/3, because we're checking if the number is between 0 and 1/3. But how do we do this? How do we check that two comparisons are both true? To do this, we're going to learn another type of operator in JavaScript called logical operators. Logical operators let us combine Boolean values, which is what we need to do here. Let's go back into booleans.html, and we're going to learn logical operators. So first, let's open the tab for this file, and we're going to comment out all the previous code so our console doesn't get too messy. /*, and then at the bottom, */. Now let's create some new lines. And the first logical operator we're going to learn is called the AND operator. Let's type console.log a Boolean value true and another Boolean value true. So this is the AND operator, and it checks if two Boolean values are both true. So it checks if the left side is true and the right side is true. That's why it's called the AND operator. So here, the left side is true and the right side is also true. So the AND operator will result in true. If we save, this displays true. Now, if one of these sides is false, for example, if we change this to false, now let's check, is the left side and the right side both true? In this case, no. So AND will now result in false. If we save, it now displays false. So that's the logical AND operator. It checks if the left side is true and the right side is also true. So this is exactly what we need for our project. For example, let's create a new line and type console.log. And let's say that we generated a random number like 0.2. And we want to check if it's between 0 and 1/3. So we can do 0.2 is greater than or equal to 0. And we're also going to check if 0.2 is less than 1/3. So we're using the logical AND operator to check if the left side is true and the right side is also true. So in this example, both sides are true. 0.2 is between 0 and 1/3. So if we save, this whole thing will display true. Now, in the order of operations, logical operators like AND have a lower priority than math and comparisons. So in this example, it will calculate the math first, and then it will calculate the comparison on the left, and then the comparison on the right, and then at the end, the AND operator checks if both sides result in true. Now let's use the AND operator in our project. Let's go back to the file for our project. And then inside this first condition, we're going to check if the random number is greater than or equal to 0. And at the same time, is the random number less than 1/3. So this is how we check if a number is between 0 and 1/3. In this case, the computer will pick rock. So between the curly brackets, let's just type console.log rock. Let's get some practice and create the other two branches for picking paper and scissors. Feel free to pause this video if you want to try it yourself first. So here, we're going to type else if to add another branch, and then brackets and curly brackets. And in this condition, we're going to check if random number is greater than or equal to 1/3, and random number is less than 2/3. So if this random number is between 1/3 and 2/3, inside here, we're going to console.log paper. And finally, let's create another branch using else if random number greater than or equal to 2/3 and random number less than 1. And console.log scissors. If we save and then go back to our rock, paper, scissors tab and then click the rock button a few times, it will pick some random moves for the computer. So that's how we generate the computer's move. One thing I want to point out is that I use the less than comparison instead of less than or equal to. I just did this so that the comparisons don't overlap. Before we continue in the project, we're going to learn 2 other logical operators we can use. Let's go back to booleans.html, and let's also open the tab for this file. The next logical operator is called the OR operator. For example, let's type some new lines and type console.log true or false. So this is the logical OR operator. It checks if at least one side is true. So it checks if the left side is true or the right side is true. That's why it's called the OR operator. So here, one of these sides is true, so the OR operator will result in true. If we save, this displays true. If both sides are true, it will also result in true, because at least one side is true. The last logical operator we're going to learn is called the NOT operator. For example, let's create a new line and type console.log exclamation true. So the exclamation is called the NOT operator. The NOT operator only uses one Boolean value, and it flips it into the opposite value. So if this value is true, the NOT operator will flip it into false. So if we save, this will result in false. Now, if you think about it, if we say that something is not true, that's the same thing as saying that it is false. So that's why this is called the NOT operator. Now, if we change the value to false, again, the NOT operator will flip this into true. So if we save, this will now result in true. So those are the logical OR and NOT operators. We don't need to use these in our project right now, but I'll leave some exercises for these at the end of this lesson. Now let's go back and continue the project. Let's open the code and open the tab. The next step is to compare the computer's move to our move, which is rock. So first, let's save the computer's move in a variable so we can compare it later. So instead of console.log, we're going to create a variable with const computer capital M move and make it equal to the string rock. And we'll do the same thing here. Const computer move equals paper. And here, const computer move equals scissors. And now at the bottom, let's console.log the computer move variable to make sure that it worked. If we save and then click our rock button, unfortunately, it gives us an error telling us that computer move is not defined, even though we created it right here. So what is happening here? If statements have a special feature. They create something called a scope. A scope limits where a variable exists. Basically, whenever we have these curly brackets like this, any variable we create inside the curly brackets will only exist inside the curly brackets. And we can't use these variables outside the curly brackets. So this is called a scope. Scopes are a feature of many programming languages, and they help us avoid naming conflicts. For example, if I create a variable here called random number equals 0.5, and this didn't create a scope, so if I delete these curly brackets, this variable name will now conflict with the variable name up here, because we can't have two variables with the same name. So you can imagine that if we didn't have scope and we had hundreds or even thousands of lines of code, we would quickly start to run out of variable names. So by creating a new scope here, all the variable names inside the scope only exist between the curly brackets, and it won't affect anything outside in the code. So scopes help us avoid naming conflicts. Okay, so I'll delete this example, and we'll learn how to access this variable outside of this scope. So to access this variable outside of the if statement, we have to create this variable outside of the if statement. So above here, we can create this variable, const computer move. And let's just make it equal to the empty string for now. So this variable was not created inside any curly brackets. So it's accessible from all of this code inside the onClick attribute, including inside the if statement. And then inside the if statement, instead of creating a new variable, we're just going to save the move inside this variable up here, because we can access this variable anywhere else in the code. So instead of using const, we're just going to reassign computer move. And we're going to remove it here as well, and here as well. And remember, when we reassign a variable, we have to switch from const to let. And now if we save and then click the rock button, we're able to console.log computer move, because computer move is no longer inside this scope. It's up here. So we can access it in this line of code. So that's how scope works. Any variable that we create inside curly brackets will only exist inside the curly brackets. So remember in the previous lesson, we learned a third way of creating variables called var. The issue with var is that it doesn't really follow the rules of scope. For example, here, if we create a variable with var, like var and random number equals 0.5, this variable will conflict with the variable up here with the same name, even though it's inside a scope. So that's why we don't use var anymore, and we just use const and let, because var doesn't really follow the rules of scope. So we can remove this for now and move on to the next step. So we generated a random move for the computer. Now we have to compare our move, which is rock, to the computer's move to get the result and see who wins. To do that, we'll use another if statement. So at the bottom here, let's type if, and then brackets and curly brackets. And then inside this condition, let's check if the computer move is equal to rock. So remember, in JavaScript, we always use triple equals instead of double equals to avoid the conversion behavior. And now if the computer's move is rock and our move is rock, then inside the curly brackets, the result is going to be a tie. And let's save this string in a variable so we can use it later. Again, we have the same situation as before. We don't want to create the variable inside here because then it only exists in this scope between the curly brackets. Instead, we're going to create the variable above, outside the if statement. So we'll use let to create this variable because we're going to reassign it in the if statement. Let's name this variable result and just make it equal to the empty string at the top. And then in the if statement, we'll save the result into this variable. So result equals tie. Now let's create the other branches of this if statement. So here we'll add else if brackets and curly brackets, and we'll check if the computer move is equal to paper this time. If the computer move is paper and we picked rock, then we lose. So the result is equal to you lose. And finally, we'll add another else if brackets and curly brackets, and we'll check if the computer move is equal to scissors. And if the computer picked scissors and we pick rock, the result is that you win. So that's how we compare our move to the computer's random move using an if statement. The last step is to display this result in the pop-up. So at the bottom, let's create a pop-up using alert, open bracket, close bracket, and let's go back to Super Simple Dev to see the message in the pop-up. So we'll click this, and in the pop-up, it shows our move, the computer's move, and then the result. So we can actually just copy this, right-click, copy, and then in here, right-click and paste. So obviously, the computer is not going to pick this move every time, and this is not going to be the same result every time. Instead, we want to insert computer move into here, and we want to insert result into here. So because we want to insert values, we're going to turn this into a template string using backticks. And now instead of paper, we're going to insert a value using dollar and curly brackets, and we're going to insert the variable computer move. And instead of this text every time, we're going to insert the variable result. And now if we save, and we can click OK to close this, and go back to our tab and click the rock button, we're going to pick rock. The computer will pick a random move and it will show us the result in a pop-up. So that's how we create this simple version of rock, paper, scissors. In our code, we did things step by step. First, we generated a random number, we converted it into a move for the computer, and then we compared our move to the computer move, and we display the result in a pop-up. So as you can see, when we're writing JavaScript, we first figure out what steps we need to do. This is called an algorithm. And then we convert these steps or this algorithm into code. So now we can actually remove this console.log because we don't need it anymore. And the last step is to make the other buttons here interactive. So feel free to pause this video if you want to try it yourself first. For the paper button, let's add some new lines to make it a little easier to read. And again, we'll add the onClick attribute. And then inside here, we can actually make a copy of all the JavaScript we wrote. So we can select all of this and then right-click copy. And then in here, right-click and paste. If the formatting doesn't look right, we can select all of these lines and press Tab to add indents until the formatting looks good. The one thing we have to change here is that now we picked paper, so the result is going to be different. If the computer picks rock and we pick paper, that means you win. If the computer picks paper, now it means that we tie. And if the computer picks scissors, that means you lose. And here we'll also change you pick rock to paper. And that's it. The last step is to make the scissors button interactive. So again, on click equals double quotes, and then we'll make a copy of the code. So I already have it, so just right click and paste. And then again, select the code that we need to fix the formatting for and press Tab. And here we pick scissors. So if the computer picks rock, then the result is you lose. If the computer picks paper, the result is you win. And if the computer also picks scissors, the result is a tie. And we'll change you picked rock to scissors. Now, if we save and try out our game, if we click rock, we're going to pick rock, computer picks a random move, and it will show us the result here. Let's press OK and try paper. This also works correctly. Let's press OK and click scissors. And this also works correctly. And that's it. We just finished creating a simple version of this rock, paper, scissors game. In the rest of this lesson, we're going to learn more details about booleans and if statements. Let's go back to booleans.html and open the tab for this file. And let's comment out the previous code using /* and */ and create some new lines. The next thing we're going to learn is called truthy and falsy values. So if statements don't just work with Boolean values like true and false. They actually work with any type of value, including numbers and strings. For example, let's type if, brackets, and curly brackets, and inside this condition, instead of putting a Boolean value, we're going to put a number, like 5. And then inside the curly brackets, let's console.log the string truthy. If we save, the number 5 behaves just like true. It causes the if statement to run this code. So we call this value a truthy value because it behaves just like true. Now let's change this value to a different number, 0. If we save, the number 0 behaves just like false. It causes the if statement to not run this code. We call this value 0 a falsy value because it behaves just like false. So how do we know if a value is truthy or falsy? In JavaScript, the list of falsy values are false, the number 0, the empty string, nan, undefined, and null. Any value that is not on this list is a truthy value. So why do we use truthy and falsy values? One way we use them is like a shortcut in our code. For example, let's create a variable at the bottom using const, and let's call it cart quantity and make it equal to 5. Next, let's create an if statement. If, brackets, and curly brackets, and inside the curly brackets, let's type console.log the string cart has products. Now let's say that we only want to display this message if our cart has products. Usually, inside this condition, we would check if cart quantity is greater than 0. But now, instead of doing this comparison, we can actually just type cart quantity, and it will behave the same way. If the cart quantity is not 0, they will both behave like true. If the cart quantity is 0, they will both behave like false. So here, the cart quantity is 5, which is a truthy value. If we save, this causes the if statement to run this code. As you can see, instead of doing comparisons, we can use truthy and falsy values as shortcuts. Truthy and falsy values also work with logical operators. For example, if we console.log the not operator and the number 0, 0 is a falsy value. It behaves just like false, so the not operator will flip it into true. If we save, this will display true. Now that we understand truthy and falsy values, let's go over the list of falsy values, because there are some that we haven't learned yet. We already learned false, 0, and the empty string. The next falsy value is nan, which means not a number. We get nan if we do some invalid math. For example, at the bottom, let's type console.log the string text divided by the number 5. So obviously, this is not valid math. If we save, JavaScript will tell us that the result of this calculation is not a number, or nan. The next falsy value is undefined. Undefined represents that something doesn't have a value. For example, at the bottom, if we create a variable with let variable1 and we don't give it a value, and then we console.log this variable, and we save, it will show us that variable 1 contains the value undefined. So undefined represents that this variable doesn't have a value. One thing to note with undefined is that we can only use this syntax with let. We can't use it with const. If we really want to use this with const, we have to type out equals undefined directly. The last falsy value is null. We'll need some extra knowledge to understand null, so we'll learn about null later in this course. The last thing we're going to learn in this lesson are some shortcuts for if statements, called the ternary operator, the guard operator, and the default operator. First, let's comment out this code so our console doesn't get too messy. /*, and then at the bottom, */. And let's scroll down, and we'll start by learning the ternary operator. We're going to type a Boolean value like true and question mark, another value, for example, the string truthy, and then colon and another value like the string falsy. So this is the ternary operator. This is similar to an if-else statement. The first value is like the condition. If it's truthy, the result of this code is the value after the question mark. If the first value is falsy, the result of this code is the value after the colon. So you can think of the question mark as the if branch and the colon as the else branch. This is sort of like a shortcut for an if statement like this. Now, an advantage of the ternary operator over an if statement is that we can save a ternary operator in a variable. So at the front, we can do const result equals. And now if we console.log the result and save, the first value is true. So the value after the question mark gets saved in the variable. As always, we can use truthy and falsy values instead of just true and false. So here, if we change the first value to a falsy value like 0, this will cause the value after the colon to get saved inside the variable. If we save, that's exactly what happens. So this is the ternary operator. It's sort of a shortcut for an if-else statement like this. The next shortcut is called the guard operator. Earlier in this lesson, we learned the AND operator, which checks if two sides are both truthy. The AND operator has a special feature. Let's say we have an AND operator and the left side is false. In this situation, we already know it's impossible for both sides to be truthy, so we don't even need to check the right side. So the AND operator actually stops early and doesn't even run the code on the right. This is called a short circuit evaluation. For example, let's go into our code and create some new lines, and we'll type false and console.log hello. If we save, the left side is falsy, so the AND operator stops early or short circuits, and it doesn't even run the code on the right. So as you can see, we can use the value on the left to block or guard the code on the right. So when we use the AND operator like this, we call it the guard operator. This is sort of like a shortcut for an if statement like this. And just like the ternary operator, we can save the guard operator in a variable. For example, let's create a variable const message and make it equal to false and the string hello. If the first value is falsy, The guard operator will stop early, and the result will be the first value. If we console.log this message and save, the value false will be saved inside this variable. Now let's change this value to a truthy value, like the number 5. Now it will not stop early, and it will give us the second value as the result. If we save, the string hello is now saved inside this variable. This is sort of like a shortcut for an if statement like this. So don't worry if it's a bit confusing. All of these are just shortcuts for an if statement. They're sort of like an if statement that we can write on a single line. The last shortcut is called the default operator, which is similar to the guard operator but uses OR. Earlier in this lesson, we learned the OR operator, which checks if at least one side is truthy. Let's imagine we have an OR operator, and the left side is true. In this situation, we already know the result of the OR operator, because the left side is already truthy. We don't even need to check the right side. So the OR operator also stops early or short circuits if the first value is truthy. For example, let's create some new lines. And let's say that in our final Amazon project, we can choose a currency to pay for our order. Let's create a variable with const currency and make it equal to the string EUR, or euros. Now let's say that choosing a currency is optional. If we don't choose a currency, we'll use a default value of USD, or United States dollars. To create a default value, we can go to the end and type or the string USD. So here, the left side is truthy. So the OR operator will stop early, and it will result in the value on the left. If we console.log the currency and save, it will display euros. Now let's say that we didn't choose a currency because it's optional. So let's go here, and we're going to change this currency to undefined. Now the left side is falsy, so the OR operator does not short circuit. It will continue, and the result will be the value on the right. If we save, now the string USD is saved inside currency. As you can see, we can use the OR operator to set a default value. So when we use the OR operator like this, we call it the default operator. The default operator is sort of a shortcut for an if statement like this. So don't worry, remember that everything that we learned in this last section are basically some shortcuts for if statements. We don't have to use them, but they can save us some typing. And that's the end of this lesson. In this lesson, we learned about Booleans and if statements. Boolean values represent whether something is true or false. We learned how to use if statements to make decisions in our code. We learned how to use comparison and logical operators. We learned about algorithms and created a simple version of rock, paper, scissors. We learned about truthy and falsy values. And we learned some shortcuts for if statements: the ternary operator, the guard operator, and the default operator. Here's some exercises to help you practice Booleans and if statements. In this lesson, we're going to learn the next feature of JavaScript called functions. And we're going to use functions to improve our rock, paper, scissors project. First, let's create a new file for this lesson. We'll go to our code editor and create a new file. And let's name this file 07-functions.html and press enter. Next, let's copy booleans.html to functions.html. So we'll click this file and then select all this code using Control A or Command A, and then right click, copy, and in here, right click and paste. And we'll hide our files and prepare this file for this lesson. So at the top, we'll change the title to functions, and we'll remove all the code in the script element. And let's save, and we'll open this file in Live Server by right-clicking, Open with Live Server. And we're going to open the console as well. So right-click, Inspect, and then click the console. And finally, we can close the previous tabs as well as the previous code. Okay, now we're ready to learn functions. First of all, what is a function? A function lets us reuse code. Let's create our first function. We're going to go to the script element and type the word function and space. So this creates a new function. And then we're going to give a name to our function. We can name it almost anything we want, but for now, let's just name it function1. And then we're going to type round brackets and curly brackets. Then inside these curly brackets, we're going to create a new line and we're going to type some code. So console.log the string hello, and we'll also type console.log 2 plus 2 and save. So this creates a function. Now let's learn how to use this function. We're going to type at the bottom the function name. So function1, and then open bracket, close bracket, and semicolon. When we type the function name with brackets, this will run the code inside the function. If we save, notice that it runs the code inside the function and displays the two lines in the console. So why do we use functions? A function lets us reuse code. So if we wanted to run both these lines of code again, all we have to do is type the function name again with brackets. So function1 and brackets again. If we save, this will run the code inside the function 2 times. And we can reuse this code as many times as we want by typing the function name with brackets. So that's what a function is. It lets us reuse code. Now let's learn the syntax rules for functions. The word function creates a new function, and then we choose a name for our function. The rules for function names are the same as variable names. We can't use special words like function, we can't start with a number, and we can't use special characters, although $ and underscore are allowed. And just like variable names, the best practice is to use camel case for function names. And inside these curly brackets, we put the code that we want to run when we use the function. This is called the function body. Now, one very important thing to remember is that this code only creates a function. It doesn't run the code in the function or do anything else. In order to actually run the code, we have to use the function like below by typing the function name with brackets. This is known as calling the function. It's also known as running the function or executing the function. Now that we learned the syntax rules for functions, let's do a practical example. We're going to use functions to improve the code of our rock, paper, scissors project. First, let's click here to show our files. And we're actually going to make a copy of the project just for this lesson. So we're going to right-click this file, copy, and then at the bottom, right-click and paste. And we're going to rename this file. So right-click, rename, remove copy at the end, and then at the beginning, we'll change this to 07 and press enter. Next, we're going to open this file in Live Server by right-clicking and then open with Live Server. And let's also open the console on this page. We'll right-click, inspect, and then click the console. All right. Now, if we look at the code for generating a computer move, you'll notice that this code is the same for all three buttons. So this is a perfect situation to use a function because a function lets us reuse code. So let's scroll down to the script element, and we're going to make a function here. So let's type function and then a function name. Let's name this function pick computer move, and then brackets and curly brackets. So one recommendation for function names is to use a verb or an action in the name, such as pick. So next, we're going to move all the code for picking a computer move into our new function. So let's create a new line here, and we'll scroll up to the scissors button because it's the closest one, and we'll select all of this code for picking a computer move, and then right-click, cut, and inside the function, right-click and paste. If we need to fix the formatting, we can select these lines and press Tab to add indents. So the reason we created this function in the script element is because remember that the script element runs when the page is loaded. So we want to make sure that we create the function first, and then we use it in the buttons after. Now remember, this code just creates a function. It doesn't actually run the code inside. To run the code inside, we're going to call this function. So let's scroll up to the scissors button, and we're going to call this function by typing the function name pick computer move, open bracket, close bracket, and semicolon. If we save and then click the scissors button, unfortunately, it now gives us an error saying computer move is not defined. Now, this might seem weird because down here, we actually create the computer move. So what's going on? The reason this happens is because functions create a scope. In the previous lesson, we learned about scopes, which limit where a variable exists. we learned about if statements, and that if statements create a scope between the curly brackets. This means that any variable created between the curly brackets only exists between the curly brackets. Functions also create a scope. Any variable that is created between these curly brackets only exists inside the curly brackets, and we can't use it outside the curly brackets like we do here. So that's why we're getting this error. So how do we solve this problem? Remember that with if statements, we solve this by creating the variable outside of the if statement, like this. We can use a similar solution with functions. To make this variable exist outside the function, we just have to create it outside the function. So let's select this code. We're going to right-click and cut and remove these lines. And then outside the function, we're going to right-click and paste. So now this variable is no longer inside the function's scope, and it can be used anywhere else in the code. So variables like this that can be accessed anywhere are called global variables. If we save and now click the scissors button, everything is working again because this code above can now access this variable. Now let's press OK, and let's use this function to reuse this code. So we'll scroll up to the paper button, and now instead of all this code again, we're just going to remove it and call the function pick computer move, open bracket, close bracket, semicolon, and also with the rock button. We'll select all this code and remove it and just call the function pick computer move, brackets and semicolon. Now, if we save and click the rock button, it works just like before. We'll press OK and click the paper button. It also works just like before. So as you can see, functions let us reuse code, and they make our code a lot cleaner by removing all the duplication that we had. Another benefit of removing duplication is that before, if we ever wanted to update the code for picking a computer move, we had to update it in 3 places in each of the buttons. But now, if we scroll down, we only have to update it in 1 place inside this function. So functions also make our code easier to update in the future. Next, we're going to learn a feature of functions called a return statement. A return statement lets us get a value out of a function. So at the end of this function, let's type some new lines, and we're going to type return, and then a value like the number 5 and semicolon. Now, whenever we call this function, it will result in a value, the number 5. So up here, when we call this function, this will result in the number 5. So we can actually console.log this, console.log, and then save and click the scissors button, and it will show us that calling the function now results in the number 5, and we display it in the console. So that's how a return statement works. It lets us get a value out of this function. Let's press OK and do another example. We'll scroll down, and this time let's change this value to the string rock. Now, whenever we call this function, it will result in the string rock. If we save and then click scissors and scroll up here, calling this function now results in the string rock. And then we display it in the console. So now let's press OK, and we'll learn the syntax rules for a return statement. So we just have to type the word return and then a value, and it will get this value out of the function. Now, instead of just a value, we can also return a calculation or a variable or anything that results in a value. So this is known as returning a value from a function. And this value is known as the return value. We also don't have to return anything from a function. If a function doesn't have a return statement, or we return without a value, like this will return the value undefined. So if we save and then click scissors again, the function will return undefined. And lastly, when we use a return statement, it ends the function immediately. So after the return statement, if we type console.log the string after and press OK here and save this file, and then click the scissors button, notice that it doesn't run this code. And that's because once we return, the code returns back to where we called the function. That's why it's called a return statement. So it's not going to run anything after the return. So we can remove this code and press OK. So now that we understand return statements, we're going to learn a better way of getting the computer move out of this function. So first, let's actually move this variable back into the function. So we'll right click and cut, and then in here, right click and paste. And delete these lines. So now we're back to the original problem. How do we access computer move outside of the function? So another solution is to return this variable. Because remember, a return statement lets us get a value out of the function. So down here, we're going to return the computer move. So this will take whatever value is saved inside computer move, which is one of these values, and return it out of the function. If we save and then click the scissors button, we were able to get the move scissors outside of this function. So what happened here is that we returned this move, and then up here, we took the move and displayed it in the console to get scissors. So that's another way of getting the computer move out of a function using the return statement. However, now we're back to this problem with computer move not being defined because we moved it back into the function's scope. So let's scroll up and remember that this return value is just a value. We can use it like any other value. For example, we can console.log it, or we can also save this in a variable. So let's do that right now. We're going to remove this and create a new variable with const, and let's just name this variable computer move to match what we use down here. And we'll use equals to save the return value inside this variable. So note that even though we use computer move here as well as here, they're different variables. This one is inside the function's scope, so it prevents it from conflicting with variables outside the function's scope. That's one of the main benefits of scopes. So now that we save the return value into this variable, and we're using this variable down here, the code should now work. If we save and click scissors, everything is back to normal. And let's press OK. So don't worry, functions can be a little confusing at first because the code is no longer simply going from top to bottom. It sort of jumps around a little bit. So let's go through this step by step. When we click this button, we're going to run this function. So the code is going to jump down here, and then it's going to run all of this code from top to bottom. At the end, we're going to return whatever is inside computer move back to where we called this function. So we're going to return all the way back here. And then we're going to save that return value into a new variable, computer move, and then use computer move down here. So following the code line by line like this is called tracing the code. It's a useful technique to understand exactly what the code is doing. Now let's compare the two solutions that we used, a global variable and returning a variable. So returning a variable like this is actually preferred over using a global variable. And that's because a scope can help us prevent naming conflicts. So all the variables inside here will not conflict with anything outside the scope. So generally, it's a best practice to keep things inside a scope if we can. Now let's move on and use this function in the other buttons. Feel free to pause the video if you want to try it yourself first. So we'll scroll up to the paper button. And then here, we're going to save the returned computer move into a variable. So const computer move, so that it matches the code down here. Make it equal to whatever is returned. And then same thing for the rock button. We're going to save the return value in a variable const computer move equals. If we save and click the rock button, it works. Let's press OK and click the paper button, and this also works. And let's press OK. So that's how we use a return statement to take advantage of the benefits of scope. Next, if we look at the rest of this code, where we compare our move and display the result, you'll notice that this code is very similar for each of the buttons. The only thing that's different is the result and the message that we display. So we can actually use functions here as well to reuse code that has small differences. To do this, we're going to need another feature of functions called parameters. So let's go back into functions.html, and let's open the tab for this file. And let's also comment out the previous code by typing /* and at the bottom */ and create some new lines. And now we're ready to learn parameters. So parameters are sort of the opposite of a return statement. A return statement gets a value out of a function. A parameter puts a value into a function. So let's do an example. Let's say that we're working on the final Amazon project, and we need to calculate the tax for our order. Let's create a function to calculate the tax. So function let's name it calculate tax, brackets, and curly brackets. And then inside the curly brackets, let's say that the cost of our products is 1,000 cents or $10, and the tax is 10%. To calculate the tax, we can do 1,000 times 0.1, which is 10%. Let's also display this number in the console. So at the front, we'll type console.log and brackets. Now let's save. And remember, this code only creates a function. It doesn't run the code inside. To run this code, we're going to call this function. So down here, we're going to type the function name, calculate tax, and then brackets. If we save, it runs this code, and then it displays the tax, which is 100 cents or $1. However, right now, this function only calculates the tax for 1,000 cents. What if we want to calculate the tax for a different amount? How would we modify this function to work with any number? To do this, we're going to learn a feature of functions called parameters. A parameter lets us put a value into a function. So let's finally create our first parameter. So inside these round brackets, we're going to choose a name for our parameter. So let's just name this parameter 1. A parameter works the same way as a variable. We can save a value inside this parameter and then use it just like a variable. So first, let's save a value inside the parameter. To do that, we're going to go to where we call the function. And then inside these brackets, we're going to put a value. For example, 2,000. This will save this value into this parameter. And now we can use it just like a variable. So instead of 1,000, we're going to type parameter 1. And it will take whatever value is inside parameter 1, in this case 2,000, and substitute it into the code. If we save, it now calculates 2,000 times 0.1 to give us 200 cents as the tax. Now, every time we call the function, we can save a different value into the parameter. For example, let's create a new line and call the function calculate tax. And this time, we're going to save the value 5,000 into parameter 1. If we save, this line of code will calculate the tax for 5,000 cents and result in 500 cents. So as you can see, a parameter lets us put values into a function, and this allows our function to work with any value. Now let's learn the syntax rules for parameters. To create a parameter, we just typed the parameter name between the brackets. Parameter names follow the same rules as variable names. We can't use special words, we can't start with a number, and we can't use special characters other than $ and underscore. And the best practice is to use camel case. Let's actually change this parameter name to cost so the code makes more sense. And save. Next, when a function has a parameter, we usually say this function takes a parameter. If this parameter should be a number, we say this function takes a number. When we put a value into the function like this, we call this passing a value into the function. Another name for this value is called the argument. And believe it or not, we've actually used functions and parameters this whole time. The first code that we learned in this course was alert. Alert is actually a function. You can tell it's a function because of the round brackets. And between the brackets, we put a string. So this is an example of a parameter. And lastly, a parameter only exists inside the function's scope. So we can only use this parameter between the curly brackets. We can't use it outside the function. Next, a function can actually have more than one parameter. For example, right now, our calculate tax function can only calculate a 10% tax. But what if we're in a different country and we want to calculate a different tax percent? To solve this, we can add a second parameter by typing after the first parameter a comma and then another parameter name. Let's name this tax percent. And now to save a value into the second parameter, we'll go to where we call this function and also type a comma and a second value like 0.2 or a 20% tax. So the first value gets saved in the first parameter and the second value gets saved in the second parameter. And now we can use our second parameter just like a variable. So instead of 0.1 every time, we're going to calculate it with tax percent. And it will substitute whatever value is inside tax percent into the code. If we save, this first line will multiply 2000 by 0.2 and give us 400 cents as the result. So we can have as many parameters as we want in a function. We just have to separate them with a comma. Now notice that the second time we call this function, we didn't give a value for the second parameter. If we don't save a value into the parameter will get the value undefined. So here, if we console.log the second parameter, tax percent, and save, it will show us that the second time tax percent is undefined. And then multiplying the cost times undefined is not valid math. So we get the result nan, or not a number. So now let's remove the console.log and we'll learn how to fix this. So to fix this, we can either pass a second value into the function, like this line, or we can also set a default value for the parameter. To set a default value, we can just type after the parameter and then add equal sign and a default value, like 0.1. If we save, the second function call will multiply 5,000 by the default value 0.1 and give us 500. So that's how we add a default value for a parameter. All right, now that we learned parameters, we're going to go back to the rock, paper, scissors project and reuse even more code. So let's go back to the file for the project and also the tab for this project. And now, if we look at the code inside each of the buttons, you'll notice that the code is basically the same for all three buttons. The only small difference is the move that we picked. So this is a perfect situation to use a parameter. So inside the script element, let's create a new function to reuse all of this code. We'll type function, and let's name this function play game, brackets, and curly brackets. Next, let's move all of this code inside the function so we can reuse it. We'll select this code and then right-click, cut, and inside the function, right-click and paste. And if we need to reformat, we can select these lines and press Tab. So the value that is different for each button is the move that we picked. So we're going to turn this move into a parameter. So at the top, between the brackets, we're going to create a new parameter. Let's name it player move. And now let's save a value into this parameter. So inside our scissors button, we're going to call this function and run all this code. So let's type play game and call this function. And for the scissors button, let's save the string scissors into player move. To do that, we'll type between the brackets here and type the string scissors. So as we learned, this will save scissors into player move. And now we can use player move just like a variable in the function. Now let's modify the code based on the parameter. So here, this code calculates the result. However, this only works if the player move is scissors. So we're going to put this in an if statement. So we'll type if player move equals scissors and curly brackets. Inside this if statement, we're going to put this if statement. So let's select this and then right click, cut, and then inside here, right click and paste. And select these lines and press Tab. So notice that we can put an if statement inside another if statement. And we did this because this code only makes sense if the player move is scissors. And finally, let's modify the code that displays the message. So here, instead of displaying scissors every time, we're going to display whatever is saved inside player move. So we'll replace it with $, open curly bracket, close curly bracket. And in between, we'll insert player move. And that's it. We modified this function to use a parameter instead of always using scissors. Now let's save and click the scissors button. And you'll notice that it works. We display the move scissors and we calculated the result correctly. Let's press OK. And we're going to use this function to reuse the code for the other buttons. So we'll scroll up. And for the paper button, we're going to use a different if statement to calculate the result. So let's actually copy this into the function. We're going to right click, click copy, and then inside the function, we're going to create another branch if the player move is paper. So here, let's type else if brackets and curly brackets. Inside this condition, we're going to check if the player move is equal to paper this time. And then inside these curly brackets, we're going to paste the if statement we copied earlier. So right click and paste. And we can select these lines and press Tab to reformat. So now we have the code that determines the result for paper. Down here, we don't need to modify this code because we're always displaying whatever is inside player move. Finally, we can scroll up to the paper button and remove all this duplicated code and just use our function, play game, and we're going to pass paper inside. So now paper will get saved inside player move, and it's going to run this if statement instead. If we save and click the paper button, in this example, I picked paper, computer picked rock, and it calculated the result correctly. Let's press OK and use this function for the rock button. Feel free to pause the video if you want to try it yourself first. So let's scroll up to the rock button. And first, we need to copy this if statement into the function. So let's right click, copy, and then inside the function, let's create a branch for rock. Else if player move is equal to rock, and then curly brackets. And inside here, we're going to right click and paste the if statement we copied earlier. And now let's select these lines and press tab a few times to reformat. And again, this doesn't need to change. The last step is to scroll up to our rock button. And instead of duplicating all of this code, we're going to remove it and just call our function instead. Play game, brackets, and then inside we'll have the string rock. Now let's save and click the rock button. So I picked rock, the computer picked paper, and we calculated the result correctly. Let's press OK. So by using a function with a parameter, we were able to reuse all of the code in our buttons. And you can see that it made our code a lot cleaner. So lastly, notice that inside a function, we can call other functions. Let's go through the code step by step so that we understand how it works. So here, when we call the play game function, we go inside here, and then we call the pick computer move function. So now we're going to go inside this function and run all the code. And then when this function returns, we're going to return back to where we called it, and then keep going and run the rest of the code. And then when the play game function finishes, it's going to return back to here. So inside a function, we can call other functions. Now, one last thing we're going to do for this code is we'll scroll down and we're just going to add some new lines to this if statement to separate the branches and make the code a little easier to read. And save. And let's scroll up. And that's the end of this lesson. In this lesson, we learned about functions, which let us reuse code. We learned how to get a value out of a function using return. We learned how to put values into a function using parameters. And we improved the code for our rock, paper, scissors project by reusing the code and removing duplication. Here are some exercises you can do on your own to practice using functions. In this lesson, we're going to learn another type of value in JavaScript called objects. And we're going to use objects to create a score in our rock, paper, scissors project. First, let's create a new file for this lesson. We'll go to our code editor and click this icon, and then click this icon to create a new file. And we'll name this file 08-objects.html and press enter. Next, we'll copy all the code in functions.html to objects.html. So we'll type here and press Ctrl A or Command A to select the code, and then right click, copy, and in here, right click and paste. Now let's hide the files for now, and we'll prepare this file for this lesson. So we can change this to objects and remove all the code in the script element. Finally, let's save and open this in Live Server by right-clicking, Open with Live Server. And let's also open the console on this page. So we'll right-click, click Inspect, and click the console. Let's close our previous tabs and also the previous code. And now we're ready to learn objects. So what is an object? An object groups multiple values together. Let's do an example and create our first object. We'll go to the script element and we'll create a variable using const, and we'll name this variable product and make it equal to open curly bracket, close curly bracket, and semicolon. So this is an object. Inside this object, we can add some values. So we'll type enter, and then name, colon, and then a value, like the string socks. And at the end, we'll type a comma, and then price, colon, and another value, like the number 1090. So inside our object, we just added two values. So at the bottom here, let's try console.logging this object. Console.log product and save, and it will display both values into the console. So as you can see, an object lets us group multiple values together. So for each of these values, we have some code on the left. This code is called the property. And using the property, we can access specific values in the object. For example, let's type and enter and console.log. We're going to type the object product and then a dot and then a property like name. So .name will access the value that is associated with the name property, which is the string socks. So if we save, it will display the string socks in the console. Let's do another example, and we'll access this second value using the property price. So we'll type enter console.log the object product and then a dot and then a property price. So this will access the value associated with price, which is 1090. If we save, that's what gets displayed in the console. Now we can also use the property to change a value inside an object. To do that, we're going to type the object's name, product, and then dot and a property like name, and just make it equal to something else, like the string cotton socks. So this code will change the value associated with the name property to cotton socks. So at the bottom, if we type console.log the product again and save, you'll notice the value associated with the name property was changed to cotton socks. So that's how an object works. We group multiple values together, and then we can access or change these values using the properties on the left. Now let's learn the syntax rules for objects. To create an object, we start with an open curly bracket and end with a closed curly bracket. Inside the object, we can put multiple values. For each value, the code on the left is called the property. This is how we access the value inside the object. We separate the property and value with a colon, and this is called a property value pair. We can have many property value pairs in an object, and we separate them with a comma. To access a value inside the object, we type the object's name, and then dot, and then the property we want to access, like name. This will give us the value associated with the name property. This syntax is called dot notation. If we access a property that doesn't exist, the value will be undefined. To change a value in an object, we can use the dot notation again. So product.name, and just make it equal to something else. Now using this syntax, we can also add a value to an object. We can type a property that doesn't exist. For example, here we can type product.new property and make this equal to something, like the Boolean value true. If we console.log the product again and save, it will add this value to the object along with the new property. We can also remove a value from an object by typing delete, and then the object product dot, and then the property we want to delete, like new property. If we console.log the product again and save, this code will delete new property from the object. And lastly, notice that an object is just another type of value. We can save an object inside a variable, and we can also console.log objects. If we check the type of this value, so type of product, and save, and scroll up in the console, it will tell us that product is an object. So let's remove this and save. And now we'll learn why we use objects. So objects make our code more organized. Instead of creating a bunch of variables for the product's values, like the name and the price and other details, we can just group all these related values together into one object. Objects also allow us to use multiple values together. Instead of console.logging each of these values individually, we can just console log the whole object and display all the values at once. So objects let us group multiple values together, and let us use multiple values together. Next, let's do a practical example with objects. We're going to add a score to our rock, paper, scissors game. So I've actually prepared a project we can use for this lesson. To see this project, we're going to go to our website and then create a new tab. And then up here, we're going to type supersimple.dev/projects/objects and press enter. So this is our simplified rock, paper, scissors game again, except in this project, when we play the game, it's also going to keep track of a score. So how many times we win, lose, and tie. And also, if we click OK, we have a reset score button. So if we play the game a few times and add to our score, and then click the reset score button, this will reset the score back to 0. So if we play the game again, the score starts from 0 again. So we're going to learn how to use objects to create this feature. Let's press OK. And first, let's create a copy of our project just for this lesson. We'll go to our code editor and click this icon to show our files, and we'll make a copy of the rock, paper, scissors project from the previous lesson. So we'll right click and copy, and down here, right click and paste. And we'll right click and rename this file. We'll remove the copy at the end, and at the front, we'll change this to 08 and press enter. Now let's hide these files, and we can close the 07 file for now. And let's open this in Live Server by right-clicking and open with Live Server. Let's also open the console on this page. So right-click, inspect, and the console. All right, now let's go into our code and add a score to our game. So remember, when writing JavaScript, a good strategy is to think about what steps we need to do. This is called an algorithm, and then convert those steps into code. So we already had an algorithm for the rock, paper, scissors game. Let's update this algorithm to include the score. So first, the computer randomly selects a move. This step will stay the same. Number 2, we're going to compare the moves to get the result. This step will also be the same. But now we're going to add an extra step. After getting the result, we're going to update a score. And finally, we'll display the result and the score in a pop-up. Now let's convert these updated steps or this algorithm into code. The first thing we need to change is we added a third step. We're going to save and update a score. So first, we need somewhere to save our score. So one place we can save it is inside a variable. Let's go to our script element, and at the top, we're going to create a variable for our score using const score and make it equal to an object. And inside this object, we're going to have the property wins. So this will keep track of how many wins that we have. We'll type colon and the number 0 because the score starts at 0, and then a comma, and then another property, losses. This will be how many losses we have, and then colon and 0, and then another comma, and ties, colon and 0. So we use an object here because these values are related to each other. You could use separate variables, but we're using an object for convenience. Another thing you'll notice is that we're creating this variable outside of a function and outside of a scope. And that's because every time we make a move, we need to update the score from last time. So in order to save the score from last time, we need to keep it outside the function. If the score was inside the function would create a new score every time, which is not what we want. So in this situation, in order to save a score from last time, we're going to keep this variable outside. Now, every time we play the game, after we calculate the result, we're going to update the score. So let's scroll down to where we calculate the result, which is here. And then below it, we're going to type some new lines and type the code for updating the score. So we can do that with an if statement. So we'll type if, brackets, and curly brackets. And inside the condition, we're going to check if the result is a win. If it is a win, we're going to update the wins property and increase it by 1. So down here, if the result is equal to the string you win, and make sure that this string matches the string up here, inside the curly brackets, we're going to update score.wins, and we'll make it equal to itself plus 1. So this is how we increase the wins property in the score object by 1. Now remember from the variables lesson that we have a shortcut for increasing something by 1. And that shortcut is plus equals 1. Next, let's add another branch to this if statement for the other two results. So else if, brackets and curly brackets, and in the second condition, we're going to check if result is equal to the string you lose. And make sure this string matches the string up here. So if the result is you lose, we're going to update score.losses property and increase it by 1. So plus equals 1. And finally, we'll check if the result is a tie. Else if, brackets and curly brackets, result equals to the string tie. And here we'll update score.ties plus equals 1. So we converted this step in the algorithm to code. The score starts at 0, and every time we play the game, after we calculate the result, we're going to update the score using this code. Now let's convert the last step into code. We're going to display the result and the score in the pop-up at the end. So let's actually go back to the supersimple.dev project, and we'll see what the pop-up looks like. We'll click one of these buttons, and in this pop-up, on the second line, we display the score. So in our code, this is the code that displays that pop-up. So how do we add a second line to the pop-up? Remember that template strings have another special feature called multi-line strings. So we can type at the end of this template string and press enter to add another line to this string. So here we can type wins colon, and we're going to insert a value using $, open curly bracket, close curly bracket. And here, we're going to insert the number of wins that we have, which is score.wins. So we'll type score.wins. Next, we're going to show the number of losses that we have. So after this, let's type a comma and losses, colon, and insert another value. Here, we'll insert score.losses. And finally, we'll type a comma and we'll display ties, colon, and insert a value, score.ties. And this will display our score in the pop-up. So let's save this and give it a try. We'll click OK, and then go back to our tab and play the game. So now on the second line, we will display the score. One small issue here is that we have a lot of spaces on the second line. So these spaces correspond to the spaces here. When we use multi-line strings, these extra spaces will show up in the pop-up. So to remove these spaces, we can just remove them in the code, like this. Now if we save, press OK, and play the game, it will show our score on the second line without those extra spaces at the front. Let's press OK. We're going to add one more feature to this project. If we go back to supersimple.dev, we have a reset score button, which will reset the score back to 0 when we click it. Let's add this button in our project. So we'll scroll up, and inside the HTML, we'll add a button with the code less than button greater than. And inside the button, we'll have the text reset score. And now when we click this button, we'll run some code using the onClick attribute equals double quotes. And then in here, we're going to write some code to reset this score back to 0. So one way we can do it is, because this score is an object, we can use dot notation to change everything back to 0. So we can type score.wins and make it equal to 0. We'll also type score.losses and make it equal to 0. And finally, score.ties and make it equal to 0. Now let's save and go back to our tab and play the game a few times to get a score. Let's press OK and press reset score, and then play the game again. And you'll notice that the score started from 0 again. So that's how we create the reset score button. We just set all of these properties back to 0. And that's it. That's how we add a score feature to our rock, paper, scissors project, using an object to save the score. Let's press OK. And we're going to learn more details about objects. Let's go back to objects.html. And we'll open the tab for this file. And let's also comment out the previous code using /* and at the bottom, // and save. Now let's scroll to the bottom and we'll do some setup. So first, let's create a variable with const. We'll name it product2 and make it equal to another object. Inside this object, we'll have the property name, colon, and the string shirt. And we're going to console.log this object. So console.log log product2 and save. So the next detail we're going to learn about objects is another way to access the values inside. We previously learned the dot notation to do this. For example, console.log product2.name. This will access the value associated with the name property. In JavaScript, we have another way of accessing values inside objects, which is using square brackets. So we'll create a new line and type console.log product2, and this time we'll type square brackets. And then inside the square brackets, we'll have a string with name. So this is called bracket notation. And this does the same thing as dot notation up here. It gets the value associated with the name property. If we save, these two lines of code both access the string shirt, which we see here. So when do we use the bracket notation instead of the dot notation? Bracket notation lets us use properties that normally don't work with dot notation. For example, at the bottom, we can type console.log product2 and then use a dot and try to access a property called delivery-time. If we save, this property will give us an error. And that's because JavaScript thinks that this dash is a minus sign and it's trying to do math. So in order to use a property like this, we have to use bracket notation. So we're going to replace the dot with square brackets and turn this into a string. Now if we save, it no longer gives us an error. And because delivery time does not exist in the object, we get the value undefined. So using bracket notation, we can also add values to the object when we create it. So here we can add a comma, and we'll add another property using bracket notation and a string delivery-time and a colon and then a value like the string 1 day. If we save, this lets us add a delivery-time property to this object. So as you can see, bracket notation lets us use properties that normally don't work with dot notation. Another feature of bracket notation is that between the brackets, we don't just have to use a string. We can use a variable, a calculation, or anything that results in a value. So you might be wondering, which one should we use? Dot notation or bracket notation? We usually use dot notation by default because it's shorter and easier to read. But if we need to use properties that don't work with dot notation, then we use bracket notation. Now a shortcut here is when we create the object, if we only have a string between the brackets are actually optional. So we can just type this. If we save, the code will still work. Okay, the next detail we're going to learn is that inside an object, we can save any type of value. So this includes numbers, strings, booleans, as well as other objects. Because remember, objects themselves are also values. For example, we can type a comma and add a property called rating, colon, and then an object, open curly bracket, close curly bracket. And inside this inner object, we can add more properties like stars, colon, 4.5. This is how many stars a product has, and then a comma, and a property called count, colon, 87. This is how many ratings a product has. So this is called a nested object, or an object inside an object. We can use nested objects to make our values more organized. So inside the product, the number of stars that it has and the number of ratings that it has are both related to a rating. So it makes sense to group them together further inside the product. Now, to access values inside the inner object, we just use the dot notation or bracket notation multiple times. For example, at the bottom, we can type console.log product 2 dot rating. This will get the value associated with rating, and this is an object. So we can use the dot notation again, count. So this will get the count inside the rating object, which is this value right here. So if we save, it will display 87. And finally, another type of value we can put in an object is a function. So in this object, let's type comma and another property, fun, colon, and we're going to create a function here. So let's type function, and we'll name the function function1 brackets and curly brackets. And then inside the function, we're going to have some JavaScript code like usual. So console.log the string function inside object. This saves a function inside the object. And this works because a function is actually just another type of value in JavaScript. But we'll learn more about this feature of functions later in this course. For now, just know that functions are also values, and we can save them in an object. To access this function, we can use the dot or bracket notation as usual. So at the bottom, we can type the object product 2 and then a dot and then the property fun. So this will access the value associated with the fun property, which is a function. And because this is a function, we can call it as usual using brackets. If we save, this will run the function here, and it will display function inside object into the console. So when we save functions inside an object, this is called a method. And we've actually been using methods this whole time. Console.log is actually a method. Console is an object provided by JavaScript, and log is a function that is saved inside the console object. If we go to the bottom and type console.log type of console and save, this will confirm that console is just an object. And if we change this to console.log and save, this will show us that console.log is a function. So log is a function that is saved inside the console object. So we call this a method. Another example of a method is math.random, which we used in the rock, paper, scissors project. Math is also an object provided by JavaScript, and random is a function saved inside the math object. So we call math.random a method as well. So we've actually been using objects and methods all throughout this course. And now we understand all the code that we've been using so far. Next, we're going to learn about built-in objects. So the console object and the math object are known as built-in objects because they are built into the language. They are provided by the language. We're going to learn two more built-in objects called JSON and local storage. And we will use these objects to improve our rock, paper, scissors project. Let's start with the JSON built-in object. This object helps us work with something called JSON. JSON stands for JavaScript Object Notation. The easiest way to understand JSON is it's basically a syntax. It's a similar syntax to a JavaScript object, but it has less features. For example, the code on the left uses JavaScript object syntax, and the code on the right uses JSON syntax. So one difference is that all properties and strings must use double quotes in JSON. JSON does not support single quotes. Another difference is that JSON does not support functions. So as you can see, JSON is basically a syntax that's similar to a JavaScript object syntax, but with less features. So why would we use JSON syntax instead of a JavaScript object syntax? A JavaScript object only makes sense in JavaScript. On the other hand, JSON syntax can be understood by almost every programming language. So JSON syntax is more universal. For this reason, we use JSON when we send data between two computers that might use different programming languages. We'll learn how to do this later in the course. We also use JSON when we store data. We'll learn how to store data in this lesson. Now that we understand what JSON is, let's learn about the built-in JSON object. The JSON object helps us convert a JavaScript object to JSON. For example, let's convert our object product2 to JSON. So we'll create some new lines and we'll type the JSON object dot stringify and open bracket, close bracket. So stringify is a method of the JSON object. So it's a function that is saved inside this object. And we can call this function using brackets. Between the brackets, we can give it a JavaScript object we want to convert, like product2. This will convert the object into JSON. So now let's console.log the result and save. And in the console, it will display the product using JSON syntax. If we scroll up, you'll notice that the function that we saved in the object is not inside the JSON, and that's because JSON does not support functions. So one thing to note about stringify is that it actually results in a string. So at the front, if we type type of and save, it will tell us that the result that it gives is actually a string. So if we remove this and save, now this JSON string is ready to be sent to another computer or to be saved in storage. Next, let's learn how to convert the other way, from a JSON back to a JavaScript object. To do that, we'll use another method in the built-in JSON object called json.parse. At the end, we'll type json.parse and brackets. And between the brackets, we can put a JSON string that we want to convert. So we actually have a JSON string up here. So let's just make a copy of this. We'll select it, right-click, copy, and let's create an extra variable to make it more clear. Const JSON string, and make it equal to right-click and paste. And now let's convert this JSON string back into an object by putting it into parse. And finally, we'll console.log this result. So console.log and save. And json.parse will turn the JSON string back into a JavaScript object. So that's the built-in JSON object. It helps us convert back and forth between a JavaScript object and JSON. Now we're going to learn the next built-in object called local storage. Local storage is used to save values more permanently. So far, we've been saving our values in variables. However, variables are temporary. They only exist on the current page. If we refresh the page or close the page, all the variables are deleted. For example, if we go back to our rock, paper, scissors project and open the tab for this project, and we play a few games and play it again, so we have 2 games. If we refresh the page, notice the score starts from 0 again. And that's because when we refresh the page, all of these variables are deleted and the score gets reset back to 0. However, if we press OK and go to supersimple.dev and we refresh the page and we play the game, notice that the score doesn't start from 0. It starts from the previous score even though we refreshed the page. And that's because this project saves the score in local storage, and local storage doesn't get deleted when we refresh the page. Now let's learn how to use local storage in our project. Let's press OK, and we'll go back to our code, and we'll scroll down to where we update the score. So here, after we update the score, we're going to save it in local storage. But first, let's learn how local storage works. So at the bottom here, we're going to type the local capital S storage object. To save a value inside local storage, it has a method called setItem. So we can type dot set capital I item and brackets, because this is a method or a function saved inside the object. And we're going to give 2 strings to this method. The first string is a name. This is how we're going to access the value that we save later. So let's use the string message as the name. And we'll type a comma, and then we'll type the value that we want to save into local storage. So local storage only supports strings. So let's save the string hello inside local storage. If we save and then go back to our tab and play the game, it will run all this code and save the string into local storage. Now let's learn how to get this string out of local storage. We'll press OK, and we'll scroll to the top. And when we first load the page, we're going to get that value out of local storage by typing local capital S storage dot get item this time and brackets. So the get item method gets a value out of local storage, and we're going to give it one string. So this string is the name that we used earlier, which was message. So we'll type the string message. Now let's console.log this result. So console.log and a bracket at the end and save. It will get the value that we saved earlier out of local storage. So we saved the string hello, and that's exactly what gets displayed in the console. So using local storage, we were able to get the value that we saved earlier, even though we refreshed the page. Now let's save our score into local storage, so it doesn't get reset when we refresh the page. So let's scroll to the bottom. And instead of using the name message, we're going to use the name score to save our score. And instead of the string hello, we're going to save the score object. Now, one problem here is that local storage only supports strings. So we need to convert our object into a string. And we actually learned how to do this earlier using json.stringify. So at the front, we can type json.stringify and then brackets around the score. And this will convert the JavaScript object score into a JSON string. And then it's ready to be saved in local storage. So if we save this and then play the game, it will run this code and save our score into local storage. Now let's press OK and then scroll up to the top. And now instead of getting the message, we're going to get the score out of local storage. If we save, now when we load the page, we're able to get the score that we saved from last time as a JSON string. The last step is instead of resetting the score to 0 every time, we're just going to use the score from local storage. Before we do that, remember that this is just a string. So we need to convert this back to an object. We also learned how to do this earlier using json.parse. So at the front, we can type json.parse and then open bracket, and at the end, a close bracket, and it will convert this back to an object. If we save, it will convert the score from a JSON string back to an object. So now we can use it up here. So instead of doing this, we'll remove it and replace it with this code. So right click, cut, and then here, right click and paste. And we'll remove console.log and save. So now when we load the page, it will load the score from local storage. If we play the game, notice that the score doesn't start from 0. It starts from the score that we had last time. Let's review what we did step by step. First, when we update our score in this code, after we update the score, we're going to save it in local storage using localstorage.setItem. Now, local storage only supports strings, so we have to convert our score object into a JSON string using json.stringify. And then after we've saved this into local storage, when we load the page up here, we're going to load the score that we just saved from local storage using local storage.getItem. And the score was saved as a JSON string. So we need to convert it back into an object using json.parse. So that's how we use the JSON object and the local storage object to save our score more permanently. Let's press OK. And the last feature we're going to add is when we click the Reset Score button, we also need to remove the score from local storage. Otherwise, if we press Reset Score and refresh, and then play the game, it would just grab the old score from local storage. So Reset Score doesn't really work here. Let's press OK and fix this issue. So here in the Reset Score button, at the end, we're going to remove the score from local storage. So we'll type local storage and then a method called .remove item and brackets. And between the brackets, we're going to tell local storage which value we want to remove. So we're going to remove the score. So we'll type the string score. If we save and we click the reset button, and then we refresh the page and try to play the game again, unfortunately, it now gives us an error. So what is happening here? So remember that we removed the score from local storage. So now when we load the page, this actually doesn't exist. When something doesn't exist in local storage, it's going to give us a value called null. And at the bottom, if we try to access any property on null, it will give us an error. So that's what we see here. So how do we solve this problem? If we scroll up, one way to solve this problem is that if there is no score in local storage, we're going to give it a default value. Let's look at how we can do that. So after this line, we're going to check if the score is null. We can do that using an if statement. If, brackets and curly brackets, and we'll check if score is equal to null. And if it is equal to null, we're going to give this a default score. So inside the curly brackets, we'll just make the score equal to the default object we had earlier, which was wins 0, and then losses 0, and ties 0. And remember, if we need to reassign a variable, we have to change it from const to let. If we save, the score will be null because we removed it earlier, and now this will give it a default score. So everything should work as before. If we play the game, you'll notice that the score starts from 0, or this default score, and everything is working again. So that's how we create the score feature in the rock, paper, scissors project, as well as the reset score feature. Next, we're going to use some shortcuts to simplify our code. So these shortcuts are things that we learned in the Booleans lesson. So remember that null is a falsy value. That means it will behave just like false. So a shortcut we can use here is, instead of checking if the score is equal to null, we can also remove this and check if not score. So not score does the same thing as checking if it's null. If the score is null, not score will flip it into true. So both of these will return true. If the score exists, it's an object, then both of these will return false. So instead of checking if a value is equal to null, we can just use the not operator as a shortcut. Now, also from the Booleans lesson, we have an even shorter shortcut for doing this. So notice here that this code basically sets a default value if the score doesn't exist. In the Booleans lesson, we learned a technique called the default operator, which is exactly what we need here. So on this line, we can remove the semicolon and type or, and then a default value. So we want our default value to be this object. So let's select it and then right click, copy, and then here, right click and paste. And I'll select these lines and press Shift Tab to remove an indent. And I'll add a semicolon back at the end. So the way that the default operator works is that if the left side is truthy, so in this case, we have a score, it will use the left side. If the left side is falsy, or in this case, the score is null, then we will use the right side as a default value. So this does the same thing as this code below, but it's just a shortcut. So now let's comment out this code using /star, and at the bottom, //. So we'll leave it here just for reference, and then save. And if we click reset score again and refresh and play the game, it will still work. So this is a perfect situation to use the default operator to simplify our code. So let's press OK. And that's all we're going to do for this project in this lesson. Now let's move on and learn more details about objects. The first thing we'll learn is the value null. So null is one of the falsy values in JavaScript. It's similar to the value undefined. They both represent that something doesn't have a value. So what's the difference between null and undefined? We use null when we intentionally want something to be empty. For example, in the previous lesson, we learned that if a function has parameters, we can give the parameter a default value. If the parameter is undefined, it will use the default value. However, if we set this parameter to null, it will not use the default value, and it will just use null. So null means we intentionally want something to be empty. In most cases though, null and undefined work the same way. Okay, so the next detail about objects we're going to learn is called auto boxing. Let's go back to objects.html and open the tab for this file. And let's also comment out the previous code so our console doesn't get too messy. So /* and at the bottom, // and save. So let's scroll down. We learned in this lesson that objects can have properties and methods. So you might be surprised to learn that other values also have properties and methods. For example, at the bottom, we're going to type console.log, the string hello, and then the dot notation, and a property called length. So strings can also have properties. The length property tells us how many characters or letters are in this string. So hello has 5 letters, So if we save, the length property will be 5. Here's another example. We'll type console.log, the string hello, and then the dot notation and a method this time. 2 capital U upper capital C case and brackets. So this string also has a method called toUpperCase. And this method gives us a copy of the string with all letters capitalized or in uppercase. If we save, it will give us hello in capital letters. So as you can see, simple values like strings can also have properties and methods. So now you might be wondering, these are strings, not objects. How can strings have properties and methods? The answer is that JavaScript has a special feature called auto boxing. JavaScript automatically wraps this string in a special object first, and this object has the property length and the method toUpperCase. So this is done automatically. We don't see the special object that's wrapped around this string. So this feature is called auto boxing because JavaScript automatically wraps the string in an object, like a box. So auto boxing also works with other types of values, like numbers and booleans. The only thing is that auto boxing does not work with null and undefined. It would just give us an error. The last detail we're going to learn about objects is a really important detail, and that is objects are references. To demonstrate, let's create a new variable with an object. So const object1 and make it equal to an object. Inside this object, let's have a property message colon and the string hello. So you might think that when we create an object like this, we create a value that has other values inside and we save the whole thing in a variable. However, this actually works a little differently. When we create this object, the actual value is created somewhere in the computer's memory. And this variable actually just gets a reference that points to that location in the computer's memory. This is like a shortcut on your computer. A shortcut points to where the actual file or folder is. So there's no way to actually see this reference, but just know that this is a reference, and the object is somewhere else in the computer's memory. So the reason it works this way is to make the language more efficient. For example, below this line, we can create a variable, const, and call it object2, and make it equal to object1. So this code doesn't actually make a copy of the object. It just makes a copy of the reference that points to the object. So this makes the language more efficient, because if we had a really big object here, it's not good to copy the entire object over and over again. Instead, JavaScript just copies the reference, which is much faster. This is called copy by reference. Now that we learned that objects are actually references, let's learn some interesting behaviors of references. So at the bottom here, we're going to change the property message in this object. We can do that by typing the object one.message property and make it equal to something else, like the string good job. And now if we console.log object1 and save, Notice that we were able to change the message property even though we created object 1 with const. And that's because this variable just contains a reference that points to the object. So const prevents us from changing the reference in the variable, but it doesn't prevent us from reaching into the reference and changing the object that it's pointing to. So just be careful when you're working with objects. Even though we use const, we can still change the values inside the object. Another interesting behavior is that on this line, we're not actually copying the object into this variable. We're copying the reference. So object 2 actually has the same reference as object 1. They actually point to the same object in the computer's memory. So at the bottom, if we type console.log object2 and save, you'll notice that for object 2, the message property was also changed, even though we only changed object 1. The last interesting behavior is that we can't compare objects directly. For example, let's go to the bottom and we'll create a new object using const object3, and we'll make it equal to an object. And then inside, we're going to have the same values as object 1. So we'll have the property message, and the value is the string good job. So now let's try comparing object 3 to object 1. So here, we'll type console.log and check if object 3 is equal to object 1. If we save, it will tell us that these two objects are not equal to each other, even though they have the same values inside. And that's because, remember, objects are references. So object 3 also contains a reference. And this code compares the references and not the values inside the object. So because object 3 is a different reference than object 1, that's why this code results in false. If we did console.log and we check if object 2 is equal to object 1, object 2 has the same reference as object 1. It points to the same object in the computer's memory. So if we save, this will tell us that these two variables have the same reference. So just remember that when you're comparing two variables that contain objects, you're actually comparing the references, not the values inside. If we want to compare the values inside, we would do that manually by checking the message property against this message property. So don't worry, object references are a little confusing at first, but the more you work with it, the more you just get used to it. The last thing we're going to learn in this lesson are some shortcuts for objects. So first, let's make a copy of object 3. We'll select the code and right-click, copy, and then at the bottom, we'll scroll down and right-click and paste. And let's rename this variable to object 4. So now let's say that we want to get the message property out of this object. We can do that by typing object 4.message. And now let's also say that we want to save this in a variable, also called message. So at the front, we'll type const message and make it equal to this value. So now, if the variable name and the property name are the same, we actually have a shortcut for this. To use the shortcut, we're going to type const and curly brackets, message, and make it equal to object4. So this shortcut is called destructuring. This will take the message property out of object4 and save it in a variable called message. So this line of code does the same thing as the code above. So let's comment out this line using // and we'll just keep it for reference. So at the bottom, if we type console.log message and save, it will display good job. So the destructuring shortcut took the property out of the object and saved it in this message variable. Next, we can use this destructuring shortcut for multiple properties. For example, let's add another property to this object using comma, and we'll add a price property $7.99. And now we can take the price property out of this object by typing after message a comma and price. So this will take the price property out of the object and save it in a variable called price. If we console.log the price and save, it will display $7.99. So that's the destructuring shortcut. It's an easier way to take properties out of an object. The next shortcut we're going to learn is called the shorthand property. So at the bottom, let's create some new lines. And let's say we want to create a new object. So we'll type const, and let's name this object